Hey, Mr. Watson again. What we're doing today in electronics, diode lab. Diodes are amazing. They are one of the most significant electronic inventions ever. So here is there's the slide, diode lab. So what do we need to do the diode lab? Well, okay, obviously we need diodes. You need 4 of them. There they are right there. Other things you need, you're going to need some breadboards, prototyping boards, right there. It's called breadboard because, well, kind of obviously it looks like bread. The other things you're going to need, a plug-in AC voltage adapter, AC to AC. Needs to be a relatively small voltage output, no more than 24 volts. The particular one I have here is a 24 volt. And then last but not least, like pretty much most of these labs, you need a multimeter. Multimeters are the thing to understand in electronics. So we have our parts. So let's start talking about diodes and what diodes do. Why are they so magical? Well, here's the schematic symbol of a diode right there. And notice you have a positive side and a negative side. So by having the positive and negative, what happens when you put an AC voltage, remember AC goes positive and then negative, it goes back and forth. You put an AC voltage to a diode, it converts it to a DC voltage, or close. Okay, so here's the process. So here's an AC voltage there, and in the middle here we have a bridge diode, and then what comes out of it is, it's not pure DC. Notice pulsating DC, but notice, compared to the input, as the input you have positive and negative going. The line in the middle is the neutral. On the output, it's just pulsing on the positive. It does not have a negative voltage output. So at that point, it is no longer AC voltage because it doesn't go negative. It's a pulsating DC voltage. In the capacitor lab, next one I said, we'll show you how to take it from pulsating DC to pure DC. Okay, here's another example of that. Okay, you have a couple different types of rectifiers that use diodes. It said, here's one using only one diode, half-wave rectifier. You have AC voltage going in, and you get your pulsating DC out. But notice, unlike when I showed you that previous picture, this one has a lot fewer pulses. Well, that's because it's only converting half of the AC signal to DC. Next one, your full wave. Here's a full wave. Full wave uses 2 diodes. And you have one facing one direction to get the positive voltage, and you have a second diode in facing the opposite direction, and its use is to get the negative voltage. When they're connected together on the output, it said you no longer have the negative pulsing. It said it'll be strictly a positive pulsing, but still, you're converting more of the voltage from AC to DC. One diode, you're converting less than half of it. 2 diodes, around 80%. When you get to the ultimate configuration, which is called a full-wave bridge, that's 4 diodes. Here's a full-wave bridge. That was also, well, on the initial drawing where I showed you how AC voltage is converted to DC. Well, a full-wave bridge rectifier using 4 diodes, around 95% efficient. So they're very much a norm. Okay, so I told you about diodes, what diodes do. Absolute magic. Some of these incredible things. As both transformers and diodes are, thanks to Mr. Tesla, they're what really made his AC power system possible. And that the AC is much more efficient for transforming voltage for long distance, but almost all electronic devices, very few things can run directly off of AC. Heating coils can, light bulbs can, AC motors can, and I just gave you the complete list. That's it. Everything else has to have the voltage converted to DC. So let's move on with this lab. So here we are. We have our diodes. So first thing we got to do, well, we're going to test those diodes. So we're going to set the meter to resistance. Now, if you have a meter that does diode testing, you can use the diode testing setting on it. Not necessary, though, if your meter does not do diode testing. And the way you test a diode is really, really easy. Like everything else, it's just connect it up, see what you get for reading. I got OL. And then you want to switch it around and connect it the other way. So I got it switched around, and I have a reading the other way. It's showing that it's got a much lower resistance in one direction than the other. That shows me that the diode is good. So you want to do that, get your readings on all 4 diodes, test all 4 of them out. Then you're ready to start setting stuff up. So initially, here's we got that breadboard. And on the breadboard, it said, on this one, I got 2 diodes put in. And notice this divider line here in the middle. So on one side of that, I plugged in a diode, and I got the band facing this way on it. And on the other side of this divider, I plugged another diode in, but I have the band facing the opposite direction. That's really key for this, because we're going to set up different rectifier networks. We're going to start with the half wave. So let's get that half wave. Well, told you we need this power adapter, so I need to plug that power adapter in. I got my power adapter plugged in. Next thing I need to do is switch my meter. So I'm going to switch it to AC voltage. And I'm going to see what I got coming out of this power supply. So when you're doing AC voltage measurements, remember the meter leads do not need to match colors. You just need to have one connected to one output, one to the other. In this case, I did match the colors, but I didn't have to. I could have hooked up the other way, and I still get the same result. And I'm reading 28.8 volts AC. So I know the power adapter is sending out AC voltage. So let's start hooking up diodes. Okay. Just for reference purpose, I'm going to connect the red one onto this diode, and I'm connecting it to the end without the stripe. Okay, the striped end of a diode is the negative end. The unstriped end is the positive end. I'm sending AC into it. It really doesn't matter which one I'm connecting it to, but I'm sending it into the positive end, so I will, on this end, if I send it into this end, on this end I will read positive voltage. So here's how we hook up the half wave. We just clip that down there. The other power adapter lead, we hook straight to the meter lead. And now what we want to do is go over here, put that on there, and get an AC reading out. And I got 14.5 volts, about half of what that power supply has coming out of it on the positive. But then I want to switch here, switch the meter to DC voltage. And what have I got coming? Oh, look at this. There. I do have some DC voltage. And quite amazingly, it's about half. Half of it's AC on the one of that, half of it's DC. So it did what it's supposed to. It converted half of the AC voltage to DC. So now we're going to connect up, use that second diode, facing the opposite direction. And we're connecting this one to the banded end. That way we have one on the unbanded end, one on the banded end, and we now have a full wave rectifier. And what we want to do is put the meter leads over here, and we want to get our Okay, so now I got full wave set up. I got 11 volts AC coming out. So it dropped down. It didn't drop down really significantly, but it's definitely not 14.5 anymore. And look at this. Here's amazing. Now, there's the DC output. The DC output definitely went up. It went from about 14.5 to 17. So, well, going from 1 diode to 2, we increased the amount of AC being converted to DC voltage. So, now for the final setup, this one's a little different. This is the full wave bridge, and here's how you set up a full wave bridge. Okay, so you need 4 diodes, and notice I have 2 of them on one side of this divide line and 2 of them on the other side. And I need to have all 4 diodes with their bands facing the same direction. They're all going the same direction. At one end, I want to plug these 2 into the same short row going across, so they're connected together. Here in the middle, as I said, on this, these 2 are same short row. On the other side, these 2, same short row. And finally, over on this side, same thing, short row, this other end. So this is set up a full wave bridge rectifier. So how do we hook up the voltage to it? Well, the power adapter actually hooks here in the middle. So we put one on one side, one on the other, and now we have the voltage going in. And for reading the voltage coming out, well, you just have to figure out where, remember AC, when it's converted to DC, if it's hooked to the positive end of the diode, you'll get positive voltage on the negative end. If it's hooked to the negative end, like here, then you get negative voltage on the positive end. So this is where I'll get negative voltage readings. Here's where I get positive voltage readings. So let's take the meter, connect the meter up, and we got our meter connected up here, and let's see what the result is. So here's the result. On the AC voltage, it has now dropped down to 9.9, significantly lower. It went from 14.5 volts to 12. Now it's down around 10. But look at this. I'm switching it to the DC voltage. And DC, I now have a 27.2 volt DC reading. That's almost 100% of the AC voltage that went into it being converted to DC. Well, that's basically how you do the lab today. That's all. Have a great day.